Now, dear students, chapter number 7, System of Particle and Rotational Motion, and we have the topic for the discussion, that is center of mass and its position coordinate of the center of mass. So, generally, we want to discuss the meaning of the center of mass. Simply, it is a point inside a rigid body where whole mass is assumed to be concentrated there. So this point is known as a center of mass. So it is a type of a imaginary assumption inside a rigid body, and center of mass can be inside or outside the body. So this is the general meaning of the center of mass we have. So the general define, it is a point inside a body where whole mass of a body is concentrated. Okay. Now, what are the coordinates which we can discuss from this diagram? Here I have assumed the body or the rigid body which having the two particles. Now, rigid body of two particle system, and we are just getting the position of a center of mass. This is the center of mass. Okay, now it is at a distance x from the O, and the two particle those lies in the right hand side and the left hand side of the center of mass. In the right hand side the particle lies, that is m2, so it having the position from the O, that is called the x2, and the m1 having the position from the O, that is called the x1. So how can we write the meaning of the position of a center of mass in the part of the coordinates? Okay, so here we can write that coordinates of center of mass. If you are just writing the x coordinate, so we are just writing that m1 x1 plus m2 x2 is to be divided by total mass, that is called the m1 plus m2. Okay, so this is the general method to be write the meaning of the x coordinate of the system. Suppose we want to write the meaning of the y coordinate. Okay, meaning of the y coordinate. So what we can write here, this is the x coordinate we have. Suppose we want to write the y coordinate for the two particle system along the y axis, that is called the m1 y1 plus m2 y2 is to be divided by m1 plus m2. So this is the y coordinate of the system. Okay, so here we have the basic general formula. Now we are just assuming that if the two particles having the same mass, this is the equation number 1, this is the equation number 2. Now we will assume some new things in the formula. Now we are just assuming that m1 is equal to m2 is equal to m. So the x can be stated in the part of that m of that x1 plus of x2 is to be divided by m1 plus m2, that can be right in the part of the 2 to m to m cancel, so easily we can write that x is equal to x1 plus x2 is to be divided by 2. So this is the general meaning of the position coordinate of a two particle system which in which the two particle having the same masses. So this is the equation number 3. So easily we can say that the center of mass of a two particle system lies at the midpoint between the m1 and m2. Okay, so this is the general meaning we have. Now we are just assuming another situation. Now assume center of mass of two particle system at origin. So we are just imagining the meaning of the x is equal to 0. X is suppose is equal to the 0, so we can write that m1 x1 plus of m2 x2 is to be divided by m1 plus m2, and easily we can state about that x2 is equal to minus of m1 x1 is to be divided by m2. So this is the general equation we have, that is called the equation number 4. Now we can easily imagine that x2 is inversely proportional to the m2. Okay, so this assumption states that if the mass of the body is the heavier, so its center of mass will be light toward it. Okay, so this is the equation number 5 we have. So it's one of the objective question we have. If in a system the mass increases, then center of mass will shift towards heavier system, heavier particle. So this is the general hypothesis we have. Okay, now the same we have the system having the number of the particle, those are the n. Then how can we write the position coordinate? So we can easily write that x is equal to m1 x1 plus m2 x2 plus dash 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 plus suppose mn xn is to be divided by m1 plus m2 plus dash 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 plus mn. So this is the general formula we have. Now we can approach the meaning of the summation here. So easily I can write that suppose summation I is equal to 1 to n mi xi is to be divided by summation that is called I is equal to 1 to n, that is called the mi. So this is the general formula of the position coordinate of the system of the n particles. Okay, so this is the general equation, this is the general equation. Okay, so this is the equation number 6 and the equation number 7 we have. Suppose we are just writing the x y coordinate of the system. Okay, so easily we can write that summation I is equal to 1 to n mi, and the yi is there with the division of the total mass, that is I is equal to 1 to n, that is called the mi. Okay, so this is the another portion we have, that is called the equation number 8 we have. Okay, now the third portion, that is called the z coordinate. Suppose we are just getting that I is equal to 1 to n mi zi is to be divided by summation of, that means I is equal to 1 to n total mass, that is called the mi. So this is the z coordinate of the system, that is equation number 9 we have. Okay, so these are the general equations we have. Now we are just assuming the situation the particle is not lying in a plane, that is in the xy plane, or the system is not lying that in the xy plane, or it lies in a space. So we can replace the equations. Now easily we can write that if you are just assuming that this now system or the particles not lying in a plane but all the particles distributed in space, then we can use the simply method that summation I is equal to 1 to n mi xi divided by total m y is equal to I is equal to 1 to n mi y, that is capital M, is to be divided by, and same similar the z coordinate we have. Now as we are just combining all the parts, so we can easily write the coordinates of the center of mass. So easily I can write that RCM is the center of mass coordinate summation, that is MIRI is to be divided by capital mass of the system. So this is the portion we have. Okay, this is the position coordinate of the center of mass. Okay, where Ri is a position vector. What is the Ri? Ri is a position vector of ith particle. Ith particle of ith particle. Okay, now we are just assuming that center of mass of a system to be considered at origin. Now center of mass is at origin. So we can write easily that RCM is equal to 0. So we can easily write that summation MI Ri will equal to the 0. So this is the one of the basic general condition we have. Now if we are just assuming that for a rigid body the mass distribution is continuous, then how can we discuss the things? Now dear students, we are just assuming that the mass distribution is continuous, then whole the body is divided into n small elements of the mass delta m1, delta m2 and somehow delta mn. So I can write the meaning of the component that in the part of the x can be stated that summation I is equal to 1 to n delta mi along with xi is to be divided by summation of delta mi, and the meaning of the delta mi is the total m. Same how we can write that meaning of the y is summation I is equal to 1 to n delta mi, and the yi is there is to be divided by a summation of delta mi is there. Somehow we have the explanation of the z coordinate also, so easily we can write that meaning of the z is there. So the z can be stated that summation I is equal to 1 to n, that is called the delta mi, and the zi is to be divided by summation of delta mi is there. So these are the general representation, as we are just assuming the mass distribution is continuous. Now we are just further assuming the situation as we are just assuming the situation that n the number of the small masses in the very large quantity, so we are just replacing the summation by the meaning of the integral. Okay, so here just I am just making this little bit changes, that summation delta mi can be stated in the part of the integral of that dm, and that is a portion of the mass that is called the m. Okay, so this is the simply method to make the calculation of the whole mass which is distributed over a body, and we are just assuming the nature that n is the very large, so we are just replacing the summation by the help of the integral method. Okay, now how I am just changing the situation. Now the summation of delta mi is multiplied by the xi, so I can write easily that integral of x dm. Now somehow I can write the another portion, that summation of delta mi with the multiply of that yi, so I can write the meaning of that y dm is there. Okay, so easily I can write the meaning that summation of delta mi and the zi. Okay, so easily I can write that meaning of that integral is there, so zdm is there. So these are the simplest representation, as we are just assuming the n is the very large, and the mass distribution is the continuous. So the coordinate portion we can write here, xm is equal to that coordinate of the center of mass in this condition. So how I am just making the change in the part of the coordinate, so I am just replacing the x is there. Okay, that makes the total x coordinate, which is to be divided by summation delta mi integral of x dm, and I can replace the summation I is equal to 1 to n, that terms that total m integral of x dm. Okay, so this is the simplest representation of a coordinate, that x coordinate. Somehow I can write the meaning of the y coordinate is there, y is equal to that is to be divided by summation of that part, that delta mi integration of y dm. So I can write easily that 1 upon portion of m and with the integration of y dm. Okay, so these are the general portions we have. Similar we can write the meaning of the coordinate of the center of mass also. Same how I can write the meaning of the z is there. Now for the position vector of center of mass, for the position vector of center of mass, now the RCM is the 1 upon m is there, integration of r and dm is there. Okay, now simply we can assume that RCM is, that is coordinate of the combination x comma y comma z is 0, So easily we can write that this implies that integration RDM is equal to 0. Okay. So this is the simplest method to represent the coordinate of the center of mass in a different manner. So here we have discussed first that what is the meaning of the center of mass we have. So first we have discussed that how can we write the coordinates of a system for the two particle system, x coordinate, y coordinate, including we have the center of mass for the two particle system in which the two particles having the same masses are there. So center of mass of the two particle system lies at the midpoint between the m1 and m2. Now we can also assume that if inside a system the mass is increases, so the center of mass will shift towards it. Okay, now how can we represent the coordinates of the center of mass for the n particle system is there. So x coordinate is there, y coordinate is there, is z coordinate is there. Okay, now somehow we have the another representations of the coordinate in which we are just assuming that particles not lying in a plane but all the particles distributed in a space, कि स्पेस के अंदर अगर डिस्ट्रीब्यूटेड है तो फिर हम उसको किस तरीके से रिप्रेजेंट करते हैं। और इसके अलावा हम ये भी बता सकते हैं कि जो सेंटर ऑफ मास के कोऑर्डिनेट हैं उसको किस तरीके से रिप्रेजेंट किया जा सकता है। ओके, नाउ सेम हाउ वी आर जस्ट एज्यूमिंग दैट द मास डिस्ट्रीब्यूशन इज द कंटिन्यूस। सो इट्स द बेसिक एज्यूमशंस वी हैव कि अगर मास डिस्ट्रीब्यूशन कंटिन्यूस है तो होल बॉडी में हम जो है वो टोटल एन मासेस, एन स्मॉल मासेस का कंटेंट हम अपलोड कर सकते हैं और इसी के बेस पर हम एक्स कोऑर्डिनेट, वाई कोऑर्डिनेट और जेड कोऑर्डिनेट को रिप्रेजेंट करते हैं। नाउ द एन इज़ द वेरी लार्ज, सो वी आर जस्ट मेकिंग द कंप्यूटेशन ऑफ द मास बाय द मेथड ऑफ द इंटीग्रल। सो आई एम जस्ट मेकिंग द एज्यूमशन दैट एक्स कोऑर्डिनेट कैन बी स्टेट इन द पार्ट ऑफ द, कि हम एक्स कोऑर्डिनेट को किस फॉर्मेट में लिख सकते हैं, 1/m इंटीग्रेशन ऑफ एक्स डी एम। ओके, इसी मेथड को हम अप्लाई करके इसका वाई कोऑर्डिनेट, जेड कोऑर्डिनेट और पोजीशन कोऑर्डिनेट ऑफ द सेंटर ऑफ मास को भी रिप्रेजेंट कर सकते हैं। नाउ वी आर जस्ट एबल टू डिस्कस द पोजीशन कोऑर्डिनेट ऑफ द सेंटर ऑफ मास इन द डिफरेंट फॉर्मेशंस। ओके, so this is the basic of the center of mass. So simply the center of mass is a center of mass is a point where whole mass of a body assumed to be concentrated, and easily we have to be discuss the position coordinate of the center of mass, okay, in the x coordinate, y coordinate and in the term of the z coordinate also. Okay.